All right. Well, the recorder is started, and I am going to talk about the exam first. And if we do have any questions about the homework assignment, we can talk about that after the discussion for the exam. All right. So let me maximize this window as much as I can. All right. There we go. And I probably will alternate between the exam PDF itself and also the notepad itself, just so that I can draw pictures when I need to. All right, so one thing at a time. First of all, the exam is an individual exam. No collaboration is permitted. Paper-based content that was prepared prior to the exam can be used as long as no interaction or collaboration is involved. So that means you bring whatever amount of paper-based material with you. That's fine. Okay. If you want to work with another student to prepare the material, that is fine too. But any exchange of that material during the exam is not okay. All right. So it means you can still work with other people, just that you cannot exchange material during the exam. Do not share or discuss any part of this exam with anyone in class or otherwise on the day of the exam, because some people may have situations happening and they may not be able to take the exam on that day. So if you don't know it, then you might accidentally give away part of the exam to the other person. In a multi-part question, an incorrect answer to an earlier part may or may not lead to partial credit for later parts. So that means, I don't think it's going to happen with this exam, but if it does, it means if a question has part A, B, and C, you answer part A incorrectly, but you answer part B in a way that is consistent with part A, you may not get full credit for part B either because you got part A wrong to begin with. But you might still get partial credit for that. All questions carry equal weights, adding up to 100%. This is actually important because once you know that all questions carry equal weight, then you can kind of think about how to prioritize the order that you answer the questions. My suggestion is to do a quick scan of all the questions, find out which one seems to be the easiest for you to answer, and start with that one. So you basically put the most difficult question to the last. Okay, because this way you maximize the chances that you can get as many points as possible before time runs out. Does that make sense? Okay. So I would also offer this advice, which people can either take or just leave it. Let's just say that we have four questions. Okay, this one actually only has three, but let's say we have four questions. You have 80 minutes for four questions, which means on the average, you can allocate about 20 minutes per question. Okay. So if I were you, I would allocate about 15 minutes per question so that I would have some time left to go back to an earlier question that I may not get a chance to finish. Okay. But that's up to you. Okay. Your strategy of how to answer the question is up to you. But just because all the questions carry equal weights, adding up to 100%, already gives me enough information to come up with strategies that I think will work for me. Okay, but you have to come up with strategies that will work for you. And the next part talks about the trace table. Okay, so I have to scroll a little bit here. So the trace table uses the following standard, blah 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 blah. It's consistent with how we do the traces in class. So this is really just me spelling out everything so that people cannot tell me, but Jack, you never told us what a trace is supposed to look like. Yes, I did, and again in the test itself. In the trace table, the following grading standard is applied, which is basically just me spelling out what does it mean to have a 4, what does it mean to have a 3, and so on. All right, so do we have any questions about the instructions for the exam, which I suspect will remain about the same for you? This part is not going to change a whole lot. So do we have any questions? Nope. Yep, go ahead. As many pieces of paper or books as you want. So as long as it is on paper, you can bring as much as you want. Now, I do want to caution, don't bring too much because if you bring too much, it can be difficult to find the specific page that you want. You can also use post-its and little tabs to help you index, where to find what, and so on. So there's no limitation of how much you can bring as long as it is not electronic. Mhm. And also starting this semester, this may be a little bit too much, but I'm going to use this policy. So starting this semester, during the exam, people, once they exit the room, they cannot come back in. So that means that if you need to go to bathroom, do it before the beginning of the exam. Okay, so during the exam, people who walk out, they cannot come back and continue the exam. All right, except for people with documented medical reasons where they kind of need to go out and come back in. All right, so next, this is the first question. Okay, so we're going to take a look at the first question, and we'll read the question and then we'll try to figure out how to answer this question. The following is the trace of an algorithm. Analyze this trace and come up with a possible algorithm that is consistent with the trace. So this is a trace. It doesn't look like a table, but it is a table. So we have line number as a column, we have variable u as a column, and then we have comments also as a column. And this question mark actually is associated with U, but because of the numbers are justified to the left and text, for whatever strange reason, this text is justified to the right. So that's why the question mark is a little bit off from the column representing U. Write your code below this line. Please be sure to indicate the line numbers. Explain why you choose the control structure based on the line number transitions in the trace. Explain the assignment statements based on how the values of a variable changes. Okay, so looking at just the line numbers, what do you think are the control structures involved in this particular program? Or at least point out what may be involved in this program. We only have talked about 5 statement types. Okay, we have assignment statements, so you have to kind of find out, okay, what are the signs of an assignment statement. We have conditional statements, right? So you have to look for signs of a conditional statement. We have also talked about a block statement, which is a little bit harder to spot, okay? But once you figure out the other control structures, then you can probably work on the block statement mechanism. And then we have the two loops. We have the do loop, and then we also have the while loop. So now you have to ask yourselves, what can I use in the trace to indicate what kind of statement is involved here? The key is about the transition of the line numbers, okay? And also, whether U is modified. So on any line or any row where U is changed, like line 32, 34, 34, and 34, what kind of statement do you think it is? An assignment statement, exactly, because yes, an assignment statement is the only kind of statement that can change the value of a variable. None other can do this. So now we already know that line 32, line 34 are both assignment statements. We don't quite know what is the right-hand side, but we know the left-hand side is what is on the left-hand side of the equal sign. A variable, and how many variables can we choose from in this particular trace? Exactly. So you don't have a choice. So it's going to be u equals to something. Okay. Now what that something is, we we can kind of decide that later. Okay. So now we already know that line 32 and line 34 are assignment statements. Line 32 only executes once, right? So even though you can say, oh, but the 16 can be 4 times 4, it can be 1 plus 15 and so on, I think just making it 16 is fine. Okay, make it as simple as you can. Okay, so we'll just say that, oh, okay, line 32 is just u equals to 16, and the reason is just because line 32 executes just once. Okay, and we, as a result of that execution, you get a value of 16. So the simplest explanation is simply that it is an assignment statement where u equals 32. All right, so I'm not writing down what I said, Okay, so you might need to write it down, or either now or later, because things are getting it's definitely getting recorded. Okay, all right. So that takes care of one problem. Line 34 is a little bit trickier because it's executed a few times. Okay, so if something executes a few times, what does it tell you about what might be containing that particular assignment statement? It's in a loop. Very good. Okay. So if it is in a loop, then we go like, okay, so we know line 34 is in the loop. Okay. And you might want to jot down those your observations in your answers too, even before you come to a conclusion. Because if you jot down your observations and they are correct, and you did not have enough time to finish the whole thing, I can still give you partial credit for you writing down your observations. But if you keep your observations in your head and you did not turn in anything, then I cannot give you partial credit, even if later on you say, well, yeah, but I actually realized that it is in a loop of some kind. I just don't have enough time to finish it. Well, I cannot read your mind during the test, right? Nor any other time. So jot down your observations even as you're working on it. It doesn't have to be formal. You can just have, I'll give you some idea of, what I mean by that. You can basically just go like this, okay? And then you say, line 34 is probably in a loop of some kind. You can see how vague it is, and it is not really formal, but it captures your thought. Okay, that is worth points. Okay, so in your test, okay, make sure that you jot down all your observations. No matter how vague it is, just try to jot it down, and because at the end of the day, if it gives you partial credit, it gives you partial credit, right? All right. So I'm gonna erase this. Okay, so I'm gonna erase it just so that it doesn't clog up the screen too much. There we go. All right. So now that we know it is some kind of a loop, then you have to ask the two additional questions, which is what kind of a loop is it? Because you have do while loops, and then we also have just while loops. One is called pre-checking, one is called post-checking. And also you have to ask, what is the condition of that loop? So we have a few questions to ask. So in this case, does it look like a pre-checking loop or a post-checking loop? You have to look at the transition of the lines too, okay? On which line do we evaluate the condition? And when the condition is true, does it travel back to an earlier line or does it travel forward to the following line? So those are the clues. So what do you think? What kind of a loop is this? Hmm? It is a post. That is correct. So if it's a post checking loop, and you can see that line 33 never really appears on the trace, what is line 33? We already know it's a post checking loop. So what words do we use to start a post checking loop? Do, exactly. So that means now we have a pretty good idea of what we can write down. Okay, so I'm going to write this on the side, okay? Because if I were to write on the lines down here, I would lose this portion here. So we can sort of say that, okay, line 32, oops, to use a pen. So line 32 is simply you gets the value of 16. Line 33 starts with a do. Line 34 is also an assignment statement of some kind, u equals to something. Line 35 is the one that is asking the question where the condition is. So this will correspond to our while. And then whatever condition is here is the condition that we can put here. Okay. All right. So, and they have to be in parentheses because of the syntax of a do while loop. So now we only have one single question left, which is what is the right hand side of the equal on line 34? Because it cannot be something that is a constant, because we can see how line 34, 34, 34, they change the value of u on every single line. So what is the pattern? In other words, you look at the value of u on line 32, and then you look at the first time on line 34, the second time on line 34, and the third time on line 34. What is the pattern? They are 3 in addition to the previous value. So that means, oh, okay, this will satisfy that requirement. In other words, this would be the simplest way to make a program that is consistent with the trace. Now, is it the only way? Probably not. Again, you can make it a lot more complex than what we see here, but this would be the simplest program that is consistent with the code that is given, with the trace that is given to you. Are we doing okay so far with this question? Okay, so this is just one style of question that I can use to see whether you understand the control structures and be able to reason things out based on what we have learned in this class. Do we have any questions about question number 1? Once again, I only captured the final answer. I did not quite capture the reasoning, but I did speak of all the reasoning verbally. So if you want to capture the verbal side, you can jot down the notes. You can also go back to the video recording and do it after class. Are we doing okay so far with number 1? Okay, so now we can move on to question number 2. Okay, so question number 2 is a forward trace. So this one is, I would say, fairly simple. Okay. So with this one, I just want you to trace the algorithm itself, just like the usual way that we trace an algorithm. So with this one, what you need to do is to understand the structure of the code. In other words, what statement is a part of which other statement? Because in this case, we have um, line, lines 8 and 9 are outside of the loop, the while loop, and then we have the while loop, but the while loop has 2 statements inside. The first statement is a conditional statement of line 11 and 12. The second statement is line 13. So the conditional statement on lines 11 and 12 is before the assignment statement on line 13. Line 13 is not a part of the conditional statement. Line 12, on the other hand, is a part of the conditional statement, which in return is the first statement inside the loop. So the parsing of the structure of this code is the first thing that you need to do, is to figure out, how the nesting or the structure, what is the structure of the code or how the code is nested. Okay, so with that already, understood, well, let me confirm this first before we move on. Do we have any questions about what I just said, about what statement is a part of which other statement? No questions? Okay, so in the test, I'm a little hesitant, but I think I can do it. I think I will promise you that I would not give you misleading indentation because I can easily do that, but I would probably just be consistent with the indentation and not try to trick you with incorrect indentation or have the indentation to contradict the actual structure of the code. So this one is properly indented. The indentation does tell you about the structure of the code. So in this case, the trace is going to start with, so we have the usual thing, except we have to kind of write it down now. We have the line number, we have how many variables here? So we'll just kind of do it one by one. We got V and then we got Z. We only got 2 variables. And then we also need another column for comments because anytime you evaluate a condition, either on line 10 or line 11, you have to tell me what is the result of the conditions because that will dictate where the code needs to go next. Okay, so now that we have this, oh, this is also a reminder. If you want to bring a ruler because you'd like to draw vertical lines that are straight, just bring your rulers. Okay, bring any writing instrument that you think would be helpful. You can bring a calculator if you want to, but I think with addition and subtraction and comparison, you probably don't need a calculator. But if you feel more comfortable with a calculator with you, that's okay too. All right. So now we will start with pre. Okay. The question is, do we need to know anything about v and z prior to the execution of the algorithm? The answer is no, because the first thing that we do to each one of the variable is to change it to a constant, which means whatever we knew about the variable is irrelevant. So we can say, yeah, we don't need to know anything about these two. And then we get to line 8. Line 8 is changing variable v to 0. Line 9 is changing variable z to an 8. And then we get to line 10. We ask the question of whether z is greater than 6. And that is true. So that's the reason why we get to line 11. Line 11 is asking whether z is less than 7. And it is also true in this case. That's why we end up on line 12. So we add 1 to v. V goes from 0 to 1. And then we get to line 13 because line 13 is outside of the conditional statement. So on line 13, we indicate z is subtracted by 1. So z goes from 8 to a 7. And then where do we go? Going forward usually is easy. It is when you have a loop and you have to go back, then people start to have a question. Okay, so where do we go back to? Line 10, that is correct. So we go back to line 10 at this point to reevaluate the condition of the loop here. So the loop says, is z still greater than 6? Yep, that is true. And then at this point, I am going to do the usual trick that I do, which is to take a screenshot. Oops, no, not that. Let's do it one more time. Because I need to scroll, in terms of the trace, but I don't want you to lose track of the algorithm itself. So I have to get that here. This one I can cancel. And where is my actual screenshot? All right, can I find it? Oh, I find it here. There we go. So let me make this always on top so we don't lose track of this, and see if that will work if I maximize the screen here, the full screen mode. Yep, that works out. Cool. All right, so we still have one more line we can go before I have to scroll. So after line 10, we go straight to line 11, which is asking z is less than 7. It is now false, which means the next line we get to. So line 11 tells us it's false. So where do we go now? Hmm? Not yet. Not yet. Because we have just concluded on line 11 that the condition of the conditional statement is false. So if the condition of the conditional statement is false and there's no else branch, we continue with whatever is following the conditional statement. So the question is, do we have anything following the conditional statement? Line 13. Yep. So we do have line 13. So now we write down on line 13, we're going to update z again. So z is going to change to a value of 6. And then we get to line 10. Line 10 is asking, is z greater than 6? It is now false. So we get to post right away. We jump from line 10 all the way to post because there is nothing after the loop. So that would be the full trace of this particular algorithm. Do we have any questions about question number 2, which is a kind of, I would say, more straightforward kind of trace? But the tricky part here is we do have line 13 following the conditional statement, even though I did not use the eye candy of braces in this case. Because the braces are not necessary, we only have one assignment statement as the body of the then branch of the conditional statement. So the curly braces are not really needed, even though it does make things a little bit more clear if I had used it. So are we good with this one? Cool. All right. So now we can move on to the last question. Okay, so in this exam, we only have 3 questions. I'm going to say this, some people can disagree, okay? But the idea is I don't want to give you busy work. In other words, I'm not going to overwhelm you with like 20 questions and each one is really just busy work. I want to give you meaningful questions where you have to think about it and your answer does reflect whether you understand the code or not, okay, the logic of the code. So this is one that has multiple parts because you can see 30% goes here and then there are some additional ones that we cannot see yet. All right, so we look at the code first. Okay, we have uh, we have quite a bit of nesting in this case, but this time I use braces to clearly indicate what is where. Okay, in other words, I'm not only relying on the indentation to indicate the nesting of the code. I use pretty clear braces in order to say, yep, this is the beginning, this is the end, this is the beginning, this is the end, and so on. All right, so with this one, let's start with the first part, which is asking, assuming y corrected as per in exam instructions, don't worry about that because this is like generated after I make the correction. Assuming y can start with any value you choose before the algorithm starts, is z equals to 2 a possible post condition for the entire program here? Explain your answer in the following space. Okay, so z can only equal to 2 because of line 48. So the question really is asking, can we get to line 48 if you can choose the value that y starts with? Now, we know that y has to start with a particular value because we don't have any assignment statement in the entire code to give y a value before the first line to evaluate the first line that relies on the value of y. So you have the freedom to choose whatever value you want for y. The question is, can we get to line 48 in this case, assuming that you can choose whatever value that you want to use for y. So now that your question becomes, or the question that you need to answer is, can I get to line 48? Okay, in order to get to line 48, how do we get there? All right, so how do we analyze this? I think having a flowchart can be helpful for those of you who prefer to have a visual, but I'm not a visual person, partially because I've been doing this for many years, but also because my thinking is not visual in nature. So in my case, I just work backwards. Okay, I look at this and go, how do I get to this particular else branch? So I get to this particular else branch. Okay, so I'm gonna say I get to this particular else branch from this condition because y is less than 71 is false. Does that make sense? So I'm looking from the innermost part of the algorithm and say, if I need to get to line 48, the most immediate reason is that I need line 45 or the condition on line 45 to be false because that is the behavior of a conditional statement. Are we okay with that statement or that observation? Okay. Okay, that's okay. That's not too hard. Okay, making y is less than 71 being false is super easy, because y can be 72, can be 100, can be 160, can be 2000, a bunch of values we can choose from. But the constraint doesn't stop here, because the conditional statement that we are currently in, being this entire conditional statement, it is in the then branch of line 44. Does that make sense? Let me say that one more time. The block that I have just indicated here is a part of the conditional statement that has the condition specified on line 44. So that means, hey, if I need to go from here to here, then I need something, another condition. Okay, this is not a good way to show it, so I'm gonna back off and draw in a slightly different way. Okay, so I can instead do the block. I can even back up the block itself, and instead I draw the block on this side. So if I look at this entire block of code from line 45 to line 49, okay, that entire block will only we only get there because y is less than 94 is true. Okay, so I'm going to pause here and see if this makes sense to you. So what do we know now? We know that y is less than 71 has to be false. We know that y is less than 94 has to be true. Are we doing okay so far? So this is the strategy. We basically undo this one step at a time. We just kind of go back out one step at a time. So now I look at where I'm currently at, which is now starting on line 44 and going all the way to line 52. This entire block, okay, so if I want to indicate exactly where we start and where we end, this is the block that we are talking about. This entire thing is the else branch of the conditional statement that starts on line 41. So that means if I need to go from line 41 to the else block, which is starting on line 44, I need y being less than 14 to be false. Does that make sense? Are we good so far? Okay. Now, is this the only way to analyze the code? The answer is no. You can probably do it in a different order. Some people like to do it from outside in, and I just like to do it from inside out. Okay, but now we have three conditions. Okay, y is less than 71 is false. Y is less than 94 is true, and then once again, y is less than 14 is false. The question is, can we find at least one value for y to make all three statements the way they are? So if you can, then we can explain the answer and go like, yes, okay? So now we can say yes, okay? So I'm just going to quote from my own observation here. Okay, I'll let you guys tell me what value of I, you just need one, okay? So the question is not asking you for the entire range of value of y that can end up on line 48. I'm asking for just one, okay? Give me one value of y that can land me over there. So my inclination is 93. Because now we can ask, okay, if y is 93, is y less than 71? Nope. Okay, good. If y is 93 less than 94? Yep. Okay, excellent. If y is 93, is it less than 14? Nope. Okay, I have just satisfied all three constraints by observing the structure of the code. So I can say, yep, one case is when y equals to 93. Okay. Are there other values that can also do this trick? I would say there are plenty. Okay. Because I would say 72 is also going to satisfy all the requirements because 72 is less than 71 is false. 72 is less than 94 is true. 74 is less than 14 is once again false. So 72 is actually the other extreme of the range of integers that can make this happen. Now, if we're talking about real numbers, then you have an infinite number of your values to choose from. But if I'm just looking at integers, I still have plenty of options to choose from in this case. Are we doing okay so far with the first part, the 30%? Okay. And I hope by now you realize that we are not doing a forward trace like we do in class. I am asking you to solve a problem that still relies on exactly what we have learned in this class, but you need to apply some problem solving thing that is ad hoc that you have to come up with at the time of the exam. Is that clear? Okay. So you can expect your exam not to be exactly the same as this, okay? So even the steps that are involved to answer your version of the exam may not be exactly the same as the steps that we do here. So you have to kind of be flexible about your mindset. Okay, when you get the exam, you have to be open-minded, read the question, figure out what the question is asking you to do, and and then start with what you know about the constructs that we have talked about this class, and not so much to go back to the practice exam or the homework assignments to go like, okay, so how do I do it exactly the same as the homework assignment or the same as the practice exam in order to solve this problem? That would not be a productive way to think about this. It would just be, okay, assuming that I did not read the practice exam, assuming I did not do the homework assignment. And this is the problem that I have. And I know about control structures, I know about nesting, I know about the behavior of loops and conditional statements. How do I solve the problem? Okay, so putting an open mind spin to solving the problem is actually going to be more uh, productive in the answering of these questions. So in the following lined space, trace this algorithm using a precondition that assumes a value in y that ends up with z equals to 2. So this is actually the easy part. Once you get the 30% of the previous one, the 70% is like super duper easy because all it takes is to go like, okay, assuming y starts with, okay, pick one, okay, 93 or 72 or 81 or whatever you want to choose between those two, just trace the code. That's all it's asking. Do you want me to do it, or do you guys go like, yeah, we kind of get it. The 70% is really the easier part. Question. I can do it, sure. All right. So in order for me to do that part, I have to kind of do that trick by screenshotting the algorithm first, because otherwise I can't really see the algorithm on once I switch to the next page. So I'm gonna have to do this. And of course, it's not going to show it because I want it to be always on top. There we go. And now we can kind of move this to a corner so it doesn't interfere with the actual trace of the code. All right, so here we go. We got line number. We have two variables in this case, y and z. So even though one is not going to have the value change over time, we still need two columns. And then we have comments over here. All right. Yeah, my penmanship is not quite as good as yours, but hopefully it's still readable. Yes? Okay. So we start with a precondition. The precondition is y has to start with some value between 72 and what, 93, I think? I cannot remember. Yeah, 93. So, any value in between is fine. I'm going to pick 80. Z is going to start with an unknown value because if it starts with any value, the program is going to get to line 42, 46, 48, or 51. Okay, one of those will execute, which means Z is going to be assigned a new value anyway that does not depend on its beginning value. So I have no reason to uh, give Z a specific value to begin with. Is that reasoning okay? All right. So now we actually work with the algorithm. We start with line 41, which is asking a question, y is less than 14 is false. So that will lead us to line 44 because we have to get to the else branch of the conditional statement that starts on line 41. So now we have another question to ask, which is y is less than 94. That is true. So we go to the line right after line 44, which is line 45. Line 45 is the third level, in terms of nesting. It is asking y is less than 71. It is false. So now we have to get to the else branch corresponding to the conditional statement that starts on line 45. That would be line 48. So finally, on line 48, z gets a value of 2, like so, and then we get all the way to post. Okay, now we get all the way to post because there are no additional statements following the conditional statement from line 45 to line 49. Okay, so there's nothing following that. So that means we have concluded the um, else branch, or the then branch corresponding to the conditional statement that starts on line 44. But the conditional statement that starts on line 44 that ends on line 52 is also the only statement in the else branch of the conditional statement that starts on line 41, which means there's nothing else that I need to process after line 52. So that's why we end up at post. Is that okay? All right. So that's it. These are the three questions in exam one last semester. You can see they're not complicated questions in terms of being tedious. Okay, I'm not giving you like 20 lines of tedious code to track. They are difficult. They can be seen as difficult in the sense of you have to apply some problem solving skills on the fly that we may or may not have talked about. Okay, but problem solving is not something that is specific to a class like this. Okay, whenever your car doesn't start up or something does not work and you need to troubleshoot, that is problem solving. So in a sense, I'm really also testing whether you can apply the knowledge that you have learned in this class specific to C++ programming, but you have to combine that with problem solving skills in order to answer these questions. Do we have any questions, comments about the exam or exam one from last semester? This is the actual exam from last semester. Any questions? So now that you know how we answered the questions from the previous semester, and you know the general way that I would ask questions, okay, how are you going to prepare for your own exam one, which is actually quite a bit away? I think that's what it's October October 1st. So October 1st is what day? Okay, let me have to go back to my. I want to double check that October 1st is the correct date. I'm pretty sure it is. I'm just a little paranoid. Okay, next Wednesday. Okay, so you got about a week, a little more than a week to prepare for the exam. So how are you going to do that? So I will give you some interesting answers. Okay, one is if you feel really comfortable with this, because I gave you the exam already, like what last week, right? And you said, I worked out this already by myself. Okay, I may not have given all the full explanation that I did in this class, but I figure everything out. I just need to learn to remember to write down all my reasoning and jot down everything. Then you are already ready for the exam. Okay. On the other hand, if you're looking at this and go like, okay, when Tech is explaining it, I get it. Okay, I understand his reasoning when he's explaining it. But if I were to figure this out by myself, I may not be able to do so. That's still a good sign, okay? Because if you understand my explanation, that means you understand the material. You just do not know yet how to apply what you have learned in order to solve the problem. So in that case, it is a way of looking at this and go like, okay, but how did Tech figure out the answer? Okay, now the thought pattern of, well, since Tech came up with these questions, of course he knows the answer. That is not going to be helpful. Right? Okay, so you have to think about from the perspective that when I explain these things, what did I use to answer these questions? Okay, in other words, it is all about clues. Okay, it's all about clues. What is this thing telling us? Like in this particular question. Okay, so let me go back to the previous page. It is all about clues. The fact that this statement here on line 48 is the only way for z to get a value of 2, that was your first clue. So once you have a clue, then you follow that clue and say, okay, if I know that we have to get to line 48, the next question is, how do we get to line 48? So now you have to say, okay, line 48 is the else branch of a conditional statement. How do we know that? That is a knowledge thing, okay? How do you parse the source code of a program? That is something that we have talked about in the class. So that is not a technique that you have to invent on the fly. You simply say, oh, okay, I understand the structure of the conditional statement from line 45 to line 49, and this is in the else branch. But how do we get to the else branch of a conditional statement? Once again, that is knowledge. The condition of the conditional statement has to be false. That has to do with the flowchart, right? How do we get to the false branch or the else branch? The condition is false. So now you make another conclusion, which becomes yet another clue, which is, oh, the condition of line 45 has to be false in order for me to get to line 48. Okay, so now instead of having one clue, you have figured out another clue. That other clue is going to say, oh, okay, so that means y has to be greater than or equal to 71. Is that okay? So basically, that is how I worked out this problem. Okay, I take the first clue and then I go like, what can make this happen? This is the result, but what can possibly make this happen? And then you go like, okay, are there a lot of choices? The answer is no. Actually, there are no choices here. It is all step by step and linear deduction in this case. All right. Is there any feedback that you guys want to tell me? Like, this is insanely difficult, or this is, yeah, I'm getting the hang of this. I'm gonna be okay. I mean, what is your take at this point? You still got about a week and a half to do it. What do you think? It's a little intimidating because this is not how high school teaches you how to do things. Okay, I can actually tell that you guys probably were, successful high school students. Okay, if you look at your grade from high school, you guys go like, yeah, I'm pretty good. Okay, I'm better than most of my peers. Okay, in high school, they don't teach in this way. They are probably more focusing on memorization, can you regurgitate, and they practice things to no end until you go like, oh, okay, I can do calculus just by muscle memory. Am I getting, am I correct? Am I consistent with your high school experience? Okay, well, I can do that because I had kids, okay, that are just a little bit older than you guys. Okay, my oldest one is 25, my youngest one is 21. Okay, so they're probably just a touch, older than most of you, but not by much. So the way I see them do the homework assignment in high school, I go like, you're just repeating the same thing over and over again until it becomes your muscle memory. But this really doesn't help you solve problems. So so I get that. Okay. But I think you guys can also learn from the way that I describe how I solve this problem and kind of integrate that into your own way of solving problems. Okay, so I think that part is probably the most challenging part. It's not so much to understand the material of this class. It's not so much to read everything over and over again. It is about how do we apply that knowledge. Okay, and I would say having a inventory of those ideas is important first. Okay, in other words, in your mind, you have to have an inventory of what we have learned at this point. We have learned about conditional statement. What exactly is a conditional statement? What is the behavior of a conditional statement? We have two kinds of loops, right? We have pre-checking and post-checking loops. Okay, what does it look like and what are the behaviors of each type of loop? So you have to get all those down, like without any doubt or ambiguation in your mind. You have to get those down all the way and go like, I fully understand what it is. This one will do this one will do this, and this one will do this. There are only two other conditional types. One is assignments. One assignment statements are fairly easy to understand. You evaluate whatever expressions on the right hand side, whatever value that becomes, update the variable on the left hand side. So that one is not too hard to integrate into the reasoning. You just go like, oh, okay, it's the only way for me to change the value of a variable. And then the block statement is the last type. A block statement gives you the ability to say, oh, okay, this space here will only allow me to specify one statement. But I really got a few things to specify here. So how do I do that? Put a block statement there. Okay, because at the end of the day, a block statement is considered to be a single statement wherever the block statement is. It's just that it can contain multiple statements inside of it. So those are the five basic statement types that we have talked about. So you really need to drill it down and have a mental understanding, a really clear mental understanding of those five statement types. Okay, because until you have that inventory in your head, you cannot look at this and understand that, oh, okay, this is a clue. Line 48 is a clue because now I can go backwards to figure out that the condition of line 45 has to be true. Well, excuse me, has to be false in order for me to get to line 48. Is that okay? So, so as you review the material, you want to kind of create your own critical study guide. Basically, it is a condensed version of my reading material, but organized in the way that you prefer to organize things, so that if you need a quick reminder of, okay, I kind of need to re I need to take a look at the behavior of a conditional statement. You can look it up. Okay, this is what it looks like in syntax, and this is the flowchart that describes the behavior. But because you wrote down your own study guide, you would know where to find it a lot faster. For the most part, this is just me. Okay, for the most part, your study guide and whatever material that you bring with you that you create yourself is more of a confidence booster than anything else. Because by the time you are done with preparing the material that you're bringing to the class of to for a just in case scenario, you have already absorbed the material. The preparation of the material is the absorption of the material. So for the most part, bringing that piece of paper is kind of like Dumbo, the elephant, bringing the little feather. Okay, it's like you don't need that feather to fly, but the feather gives you the confidence that you can fly. Is that okay? All right. So I would say for the entire discussion up to this point, the part that is the most difficult for me to teach, okay, because everything else is just a technique, okay. Make your own study guide. That's a technique, okay. It's you can choose to do it, or you can choose not to do it, or you can choose to do it your own way, whatever, right? So those are all skills, things that you can actually do. The most important thing that I cannot really teach is whether you have the clarity and the precision in your mind to know whether you fully understand a concept or not. That is something that I really cannot teach. Am I conveying this okay or not? So that is a part where you have to kind of look inside and ask yourself, okay, when I'm studying something new, okay, from high school, it can be physics, a concept in physics, it can be a concept in calculus and whatnot. When I'm encountering something new, do I know when I don't fully grasp the concept? I know enough to solve a problem, and yet I don't know enough to fully understand why it works. Understanding, knowing, okay, I shouldn't say understand, knowing how something works does not necessarily mean that you know why it works. So you have to kind of delineate those two questions and ask them separately, okay? Because with calculus, a lot of that is pattern matching, right? I want you to do the differentiation of this particular formula here, okay, or expression. You just reapply things that you have learned from the past. But why does it work? Okay. Does your teacher, high school teacher in calculus, does that teacher teach you about the delta epsilon principle? Okay. You guys can tell me now. I kind of have a general idea of the answer. Yes, go ahead. Oh, you never took calculus? Well, that's okay. For Did anyone took calculus in high school? No one? Okay, how about in algebra? Can you remember? Okay, why do we have the commutative rule? Commutative rule means x plus y equals to y plus x. Okay, we know that rule. We know how to apply that rule, but why does it work? Have you wondered why it works? Or can you convince yourself that, oh yeah, I'm pretty sure it works because of this? It has to do with when you draw a picture of how to add, okay, whether you're adding three things to five things, or whether you're adding five things to three things, they all add up to eight. Okay, and that's the reason, okay, or this is one visualization of why the commutative rule of addition and multiplication works. Okay, so we are not talking about something quite as deep as algebraic rules in this class, but nonetheless, you still need that ability to figure out, am I fully understanding this, or am I only having a surface understanding of the words themselves, but not the meaning of the words? Okay, so that is kind of like a mental exercise you have to kind of check with yourself. Okay, but I do have one more recommendation. This one is something that you can actually do. Use the TA, use the Chat GPT TA, and say, okay, this is a question that was asked in the exam. Okay, can you ask me something of this nature? And ChatGPT, I think, is fairly good at imitating a style of question and give you an alternative. Go like, okay, let's try to solve this one, okay, which is not exactly the same, but in the same style as what I used, in the previous exam. So that's another resource that you can use. Or you can ask ChatGPT to be very exact, like, I really need to make sure that I fully understand the concept. Can you ask me a question, okay, to make sure that I understand? And then you give it a list of concepts. And in this case, the five concepts would be assignment statements, block statements, conditional statements, do statements, and while statements. Okay, and you can basically have a conversation with ChatGPT to go back and forth until you feel okay. I think I'm getting it. Okay, am I doing okay so far in terms of making some recommendations? Yes. Why is less than 94 true? Well, because because in order, okay, because we started off with this line, which is within this block here. So in order to get to the block or the statement from line 45 to line 49, which is the then statement of the conditional statement on line 44, that is why I need y is less than 94 to be true. Because line 45 to line 49 is the then branch of the conditional statement that starts on line 44. So that question, okay, is telling me that um, drawing a picture of the structure of the code first, and then draw a picture of the flowchart, which is the behavior of the code, is going to be helpful to you. And that is, I think that really is the value of having a actual professor is I'm not trying to nitpick, I'm not trying to criticize, I'm trying to use the question that you're asking me to tell you something, to give you a recommendation of what would be helpful to you. So in your case, it would be the structure of the code and the flowchart, which we have done several times in the class. Okay, remember, I draw out the structure first and then I construct the flowchart. One tells you about what is containing what. That's the structure or the syntax tree. The other one, which is the flowchart, tells you about the behavior of the code. So once you have both of them, then you probably will be able to figure out, oh, okay, we are just traveling the branches backwards and figuring out, with all the diamonds, which side of the diamond do I have to come out of? So that's basically the other way to look at this. All right. Yep. Hmm. Can I turn that code into a flowchart? Sure. Let me wake up my super note because after a certain amount of time it just decides to go to sleep. All right, so I can go ahead and make the flowchart for this code, okay? And let's go ahead and do just that. So to do that, I have to get out of here and go to notes. Uh, Here, there we go. And put it in the right orientation. Get to a new slide. New slide right here. Okay. Um, I'm making sure that I'm still recording. Okay, I'm still recording. I did not, click anything accidentally to stop the recording. So this is all recorded, which is good because if I'm talking a little too fast in the class and you do not have enough time to formulate your question or to absorb the material, you can watch it again. Okay, and my recommendation of watching my own video is to pause. Okay, after a certain section, even if you think you get everything, just give it a pause. Okay, click on the pause button or a space bar, and to kind of go like, okay, am I getting everything? And if you go through your mind and you go like, yeah, I'm pretty sure I got everything, then you can unpause and keep going. Okay, because you're trying to watch the whole thing continuously may not be very helpful. Okay, I have encountered YouTube videos that talk about psychology and other things where I go like, okay, this is enough. Click, pause, and then I have to think about it, jot down some notes, okay, before I can unpause it. So I think when people watch my video, it's about the same. Okay, so now we can go ahead and take a look at the structure. So I'm just going to do the flowchart, but not so much the structure. Okay, so we can see that on line um, 41, it is asking a question. It is the beginning of a conditional statement. So what we need to do is to have a diamond because this is the structure of a conditional statement. You ask a question, and then two branches come out of it. Okay, some people like to draw it like this. Some people like to draw it like this. It really doesn't matter. Okay. Um, so you can make one the true branch and then the other one the false branch. I'm just going to do it the more conventional way, which is to draw the else branch on the other side like so. So now the question is, what happens when it is true? Okay. So what happens when it's true is just line 42 itself. That's the only thing that we do when the condition is true. So we say, oh, okay, z equals to 0. Otherwise, we have line 44 all the way to line 52. Okay, so that's the first thing that we need to recognize is the else branch corresponding to line 41 is from line 44 all the way to line 52. Is that okay? Are we good so far? That has to do with brace matching, okay? Because the open brace on line 43, which is this brace here, is only matching the closed brace of line 53, which means everything in between is a part of a block statement. The block statement technically starts on line 43 after the else, and it ends on line 53. That entire block statement is the else statement corresponding to the condition that is specified on line 41. Is that okay? All right, so that has to do with the nesting or the structure of the code. So in the diagram, we can say, oh, we just have a big, gigantic chunk of code here. Okay, give it a lot of space. And then with any type of conditional statement, the two branches have to merge before we get out of the conditional statement. So we can draw this part. This is the template of a conditional statement. Regardless of what is inside the conditional statement, this is the template. We have a then branch, we have an else branch, and the two branches will merge at the end. Is that okay? So every time you see a conditional statement, you go like, yep, this is what we know this is going to happen. So what is inside the block statement? The first thing inside the block statement is line 44. So line 44 says, yep, we have another conditional statement. So you automatically go like, yep, we have a then branch, we also have an else branch. Okay. In this case, the then branch is the bigger one because the then branch in this case is from line 45 all the way to line 49. The else branch is only line 51 itself. So we'll do the else branch first because it's the easy one. Z simply equals to 3. But because it is a conditional statement, we know how it ends. Okay, the two branches have to merge before it exits. Are we still doing okay so far with the construction of the flowchart? Okay, it is one level at a time. Okay, I know how some people like to read the code line by line and try to construct the flowchart in the same order. That's not how I do things. Okay, I like to do it one level at a time. All right, so now we go to this empty block here and go like, okay, what goes here? Well, what goes here would be the logic from line 45 to line 49, which is another conditional statement. Because when you look at line 45, it tells you, oh, we got another condition. But before we go too far, we have to say, okay, we have a condition here, which is y is less than 94. Okay, so now we have another conditional statement inside here. So I just go straight to drawing the structure of a conditional statement first. This is true, this is false. Now, do we need the true branch to be on the left-hand side and the false branch to be on the right-hand side? The answer is no, you can kind of do it any way you want, okay? But having consistency is good, okay? So if your consistency is, I prefer to put the false branch on the left-hand side and the true branch on the right-hand side, you can do it, but do it consistently. Okay. So now we go back in, backfill what is inside the condition and what is on the left hand side, what is on the right hand side, and so on. So now we go to line 45. Line 45 is asking, is y less than what, 71? Right? Yep. And then if it is true, then we go to line 46, which says z equals to 1. Else we go to line 48, which is z equals 2, and that completes the entire flowchart and all the levels of nesting indicated as well. So with this, I basically am asking the question, we know that we have to end up here. Okay, that's the 30%. The first part of the question says we have to end up here. Let me use the mouse pointer so we can actually see what I'm pointing on the screen for people who hopefully will be watching this. So we know that we need to end up here. The question is, how do we end up here? Well, go backwards. The only way to end up here is to follow this arrow backwards. So we now know that, oh, y is less than 71 has to be false. We got a whole lot of values where, they are all not less than 71, like 72, 93, 120, and so on. But how do we get here? You go backward again. We get to here only because of this branch here, which means y is less than 94 has to be true. Oh, now we have some restrictions because I have a lot of values that are greater than or equal to 71, but only some of those are also less than 94. So how do we get here? Go backward again. We get here because we took the false branch of y is less than 14. So we also need y to be less than 14. That's not too hard. Okay, anything that is less than 14 is also, oh, excuse me, let me rephrase it because I phrased it incorrectly. Anything that is not less than 71 is automatically not less than 14. So that part is kind of like, okay, we don't have to worry about that too much because if I have a value that is greater than or equal to 71, it is automatically greater than or equal to 14. So is that okay? So there are a few parts here, right? The first one is how do we go from the code which is written in text, okay, what you see at the upper right corner here, how do you go from here to here? That is the first question. So there are several possible answers I can think of. I can do it in my head. Okay, in other words, in my head, the flow chart does not need to be drawn on the piece of paper. Okay, but that's only because I've been doing this for years. Okay, but even when I was a computer science student the first time, I did not need to do that either. because before I took the first computer science class, I already have programmed calculators for years from high school. So I have the experience already of how to look at things. But if you don't have that prior experience, which is fine, this class has no prerequisite, then you draw the picture first. Okay. Given that there are only three questions and we have 80 minutes, you do have the time to do something like this. Okay. Draw the picture first. Okay. So once you, but translating from the code to the picture, going from here, the text representation, to the flowchart or the pictorial representation, that takes practice. Okay. We talked about it in the class. We know how to do it. The more you do it, then the faster you can do it in the exam. So that part, the efficiency of doing this part is practice. Are we good so far? All right. So the most tricky part is what I just explained here. We know we have to get here. How do we know how we can get here in the first place? Just travel backwards. And every time you go through a branch that has a label, then you say, oh, okay, the condition has to be true or the condition has to be false. Then you have the constraint, all the constraints that you need in order to go like, oh, okay, to end up here, we need all of these things to be the constraints. So the question is, can all of these constraints be true, be satisfied at the same time? Sometimes you can, sometimes you cannot. Okay, so I'm not saying that you can always figure out the answer because sometimes it simply cannot happen. This also explains why after we get to line 48, we go straight to post. Because after line 48, we go to this merge point, which then goes to this merge point, which then goes to this merge point here. There is nothing that is worth tracing in between until we get all the way out of the entire algorithm. So that is why we go straight from line 48 to post because there's nothing in between that we actually do anything about. Are we good so far? All right. So do you still want to talk about the homework assignment? See what I told you? Because the explanation of this can help you with understanding what the homework has to do, because the homework is kind of like a combination between this and loops, right? So once you have a picture, the flowchart of the loop with the structuring, of the text, then you can follow it. Yep. All right. Are there any questions I can answer? Because this is pretty much the only thing I have planned for today, which is going over the exam and kind of giving you guys an idea of what it is about, what I'm really testing for, and what I can suggest you guys to do to prepare for the exam. So have I hit all of those points, or if you guys have any questions like, oh, but Tech, you didn't quite talk about this, let me know and I'll be happy to try to backfill whatever I have missed. Any questions? No? So would you have preferred to take this class online fully asynchronously? Not the way that you teach it, Tech, but do you think this is going to help prepare you for the next class? Because reasoning is the most important part. Okay, you may not even work with C++ ever in your career. You may be programming in Python for the entire career. You may be doing some quote unquote vibe coding for your entire career. But one thing you cannot avoid doing in the field of computer science or software development or software engineering, that's reasoning. That is the one thing that you cannot escape from is reasoning. And that is the one thing that I really want to make sure that you guys learn in this class and all the subsequent classes, because that's the one thing that you have to, if you have to take out one thing, the one thing they have to retain from your entire college experience, it is, okay, there are two things. Okay, let me correct myself. One is reasoning. The second one is how to learn things on your own. Right now, you may not be quite there yet, okay? And that's why I'm still employed. But at some point, okay, I hope you guys can learn enough that when you have to learn something new, you will have the skill set and all the um, necessary mental processes to do your own learning. Okay, so that's kind of the long-term objective, but this is the first class. I'm not too ambitious. I hope you're not too ambitious either, but this is the first exam. So are we good? All right. So I'm done, with today's lecture. If you guys have additional questions, I'll be more than happy to answer. If not, we'll just kind of call this class, ending a little bit early. And but I'll still have office hours every morning from 8 to 9. Okay, just in case you have any questions. If the door is closed, just knock on the glass door, and I'm usually inside my office. All right. So let me stop the recorder and upload.